Hi science friends. Today we are going to be drawing Lewis structures with ionic and covalent bonds. So this is actually not in your notes today. So if you want to jot a few things down, then that will be fine, but it's not in your notes packet. So ionic bonds, remember, are made with a metal and a non-metal. So those metals typically have a positive charge. The non-metals have a negative charge. And so they're made up of ions that are put together to form an ionic compound, and they're held together by an ionic bond. So generally what happens, in an ionic bond, electrons are transferred, okay? And they're transferred from the metal or from the positive ion to the non-metal or to the negative ion, okay? So if we were to draw a Lewis structure for sodium, sodium is a metal in group 1, so it would have this one valence electron, okay? And if we were to draw a Lewis structure for chlorine, chlorine is in group 7, a halogen, and so it would have 7 valence electrons. Well, sodium, a +1 ion, frequently combines with chlorine, a -1 ion. Chlorine needs one more valence electron, and sodium has one valence electron that it's ready to donate. And so what happens is sodium donates that valence electron to chlorine, and we'll put it right here, okay? That's the one right there that came from sodium. Actually, I'm going to mark it with an asterisk to show that it came from somewhere else, okay? So today, when you draw these on your paper, I would like for you to use 2 different colors to show which electrons came from which element, okay? So if you draw this together, you would draw it in a way that looks like, I'm going to draw sodium's with an asterisk again, and then chlorine with its 7 valence electrons, because I can't change colors on my pen here, okay? So sodium donated this one, chlorine gave all of the rest, the other 7. Together, they share, I'm sorry, they don't share. Sodium transferred that electron to chlorine. Okay, now sodium has a full octet because it got rid of this one and it dropped back to its previous valence shell before that, and so it has a full octet, and chlorine also has a full octet, so everybody's happy. Okay, so that is an ionic bond. That is how you draw those, showing where the electrons came from. Okay, in ionic bonds, electrons are transferred. Now, the other type of bond that we're going to talk about is a covalent bond. And in a covalent bond, electrons are shared. Okay? So, covalent bonds generally occur between 2 nonmetals. And generally, those nonmetals both have a negative charge. So, let's look at an example like Cl2. Okay? So, chlorine has 7 valence electrons, and there's 2 chlorines. So we've got 7 plus 7 or 14 valence electrons. We always need to know how many total we have when we go to draw our Lewis structures, okay? So I'm going to put my 2 chlorines here. I'm going to do simple dots for one of them, okay? And then I'm going to do X's for this one because I can't change my pen to be blue or a different color, okay? And so what you see here, is that they share this set of valence electrons. So this chlorine has 8, and that chlorine has 8, sharing this set in the middle. And so both of them have satisfied their octet, okay? Now, some elements or compounds, let's do one that's a little bit more complicated, like NH3, okay? So nitrogen has 5 valence electrons. Hydrogen has 1 valence electron, but we have 3 hydrogens here, okay? So total, we're going to have 8 valence electrons. So hydrogen is a little bit of an exception. Hydrogen doesn't want 8. Okay, I don't know what I drew there. Hydrogen does not want 8. Hydrogen wants 2. That satisfies hydrogen. It can only hold 2. You will never, ever, ever see a hydrogen that looks like that. That is wrong. Hydrogen will only ever have 2 valence electrons on it. Okay? Never put more than 2 dots on hydrogen. So let's look at this. So we're going to draw our nitrogen. Now, when we draw Lewis structures, we always want to make them as symmetrical as possible. So I'm going to put nitrogen in the middle, and I'm going to put hydrogen surrounding it. Now, it doesn't matter if you would have put the other hydrogen over here. That would have been fine. That doesn't matter, okay? And then I'm going to put my valence electrons on nitrogen, okay? Now, this is going to matter just a little bit where they go, and I'm going to show you why, okay? So nitrogen is going to be these dark red dots. So it has those 5, 1, 2, 3, 4, 5 valence electrons that we said that nitrogen has, okay? Now, each hydrogen likes to donate 1. So this hydrogen I'm going to put in as an X, okay? It donated that one. This hydrogen I'm going to put in as a triangle. It donated that one. And this hydrogen I'm going to put in as a square. It donated that one, okay? So what we have now, all of the hydrogens have 2 valence electrons all on them. Oxygen has 8 valence electrons on it. And we have 2, 4, 6, 8 valence electrons total, which is what we said that we needed, okay? So everybody's happy. Hydrogen's happy with 2, nitrogen's happy with 8, and we've got the correct total amount, okay? And they're sharing these electron pairs here as they would in a covalent bond, okay? Now, there are a couple other rules that you need to know when we do covalent bonds. So the hydrogen rule was 1. Let me clear my screen. Oops, didn't really mean to do that. Let me, here we go. Another rule that you need to know is oxygen likes to form a double bond. Now, what is a double bond? Normally, a single bond is 2 electrons. When we drew our NH3 here, or when we drew our Cl2 here, they were held together by 2 electrons, and that represents a bond. A single bond shares 2 electrons. A double bond shares 4 electrons. You can also have a triple bond, which shares 6 electrons. And nitrogen likes to triple bond, okay? Carbon is also liking to double bond. Carbon generally likes to make 4 bonds. So maybe that's 4 single bonds, maybe that's 2 double bonds, or maybe that's a triple bond and a single bond. But carbon, because it has 4 valence electrons, likes to make 4 bonds, okay? Oxygen likes to make a double bond. Nitrogen likes to make a triple bond. That doesn't mean that every time they're going to do it that way. Nitrogen here made 3 single bonds. So there's no triple bond, but there is 3 single bonds there, okay? But on your assignment today, the first page you have to draw bonds for ionic compounds, and the last page you have to draw, or the back, you have to draw bonds for covalent compounds. And number 12, it tells you that you have to draw a double bond, okay? So let's look at an example where we have a double bond that shares more than 2 pair of electrons. So these are a little bit tricky, okay? But you can do them. They're kind of just like a puzzle to try to figure out how it works. So CO2 is a great example, carbon dioxide. So carbon has 4 valence electrons. Oxygen has 6 valence electrons, but we have 2 oxygens. So we have 4 plus 6 plus 6 which is 16 valence electrons total, okay? We're going to want to try to draw this where it's symmetrical. So I'm going to put carbon in the middle and oxygen on the sides, okay? Now, I'm going to show you the correct way to draw it. And then I'm going to explain why this is the correct way. So this is the correct Lewis structure for carbon dioxide, okay? I have 16 valence electrons here. 2, 4, 6, 8, 10, 12, 14, 16. 16 valence electrons, okay? This oxygen has 8 that touch it. This carbon have 8 that it's touching. And this oxygen also has 8, okay? Here in the middle, these valence electrons represent our double bonds, okay? Carbon is forming 4 bonds, which I told you that it said it liked to made up of 2 double bonds. And then oxygen is forming those double bonds like I told you that it liked to, okay? You can try to draw this a lot of other ways, but you won't make it happen where everything fills the octet rule. So let's try it like this, okay? I'm just going to show you that it doesn't work, okay? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Well, I've got to have 16 valence electrons. So that fills the octet rule, but it doesn't work, okay? And you can draw many other versions of that. You could probably try to put a triple bond in here and get rid of some of these sets of electrons, but it doesn't work. You have to draw it like this. That's the only way you can make a Lewis structure that fills all the rules. That's symmetrical as best as you can, that has 8 valence electrons on every element, and that has fills the octet for all of the elements, okay? Oxygen had 6. These, let me make them bolder. These were the 6 from that oxygen. These were the 6 from that oxygen. And then these were the 4 from the carbon. So everybody donated their electrons together in a way to share them that satisfied the octet for all of the atoms, okay? So again, this is a little tricky. Sometimes there's not perfect cut and dry rules, but we just play with it and work at it a little bit until we get a Lewis structure that works, okay? So today's, fortunately, aren't too tricky. Number 12 is by far the hardest one, but if you run into problems and get stuck, then reach out and I'm happy to help. And if y'all don't have any questions, then have a great day.